intelligence. So it's a big topic today, and possibly a contentious one too. But let's take a look. And then before we wade into the murky waters of the protocols, let's just take a quick look. But did you know, I guess, before we get into this, we're going to go slightly off on a tangent. Did you know, smart buildings or not, is really just a first part of a step into a full digitalization for every business. So it's not just about the smart building. It may be for you today, and it may be what you're interested in. But I think we should be thinking about it as a full digitalization for the whole of our business. So the smart building becomes a piece of the puzzle, a part of our business intelligence, actually. From employers to customers, the ability and often the need to digitalize everything we're going to do is key now to how we'll thrive, and in some cases actually survive as a business. I don't think it's a bad thing, however, and it will often help us to solve problems, new problems that we could never easily solve before, or provide us with information that might help us to change the game. It will definitely also help us all to be better custodians of planet Earth. So just before we jump in, a few digitalization examples could be retailers using digitalization technology in stores, maybe to follow the customer journey, in this case, quite literally, maybe using positioning. It could be understanding footfall or where buyers linger. That information then could be crucial to how they go about their business. It could be a manufacturer, say a manufacturer of smart showers, for instance, using technology to understand the real product performance and the life, because then they can use real field data, live field data, in fact, to improve the product and to make sure that it is durable enough. Or it could be a manufacturing plant removing manual labor tasks using technology, such as counting how many widgets have been screened by the quality controller without him needing to stop every time and write it somewhere. We can really digitalize labor intensive tasks. So it goes way beyond what we traditionally think of as just smart buildings. And digitalization is the key to efficiency, cost, and streamlining of all the better processes that we have. And then there's often unique problems that are coming down the track, some that we've yet to even get sight of, some that have been around for years. Digitalization can be a really positive catch-all for now and for the future. So we think it's a good thing, but definitely keep an eye on, what's happening in terms of a wider digitalization of your business. But I guess I digress. So back to the task in hand. So why does it matter? Well, let's take a look at a few areas to consider immediately. The cost. The cost is always important. Apparently, it happens, but I've never heard anyone say cost is no object. So it's going to matter. The complexity of what you choose, how you go about your smart building protocol can really make a difference. So there's some businesses that have, lower general technology capability of the workforce, or some that have really challenging requirements. And of course, there's the performance, and I don't mean just the business performance, I mean the device or the protocol performance. It's pointless investing in a type of technology that just doesn't fit the environment or the application that you need it for. Then there's the energy or the power that it takes, because that could be important, in how much it costs to run, possibly how often maybe battery powered devices will last without needing the batteries to be changed. That, for instance, could be really important. And even the total energy needs of the system. It's pointless putting in a brilliant system that is not very ecologically friendly, for instance. And then finally, there's the interoperability. I mean, this is vitally important. So trying to put a system in today, but preparing for the future is a big thing, because often we're investing lots of time, money, and effort in, how we go digital. So these are some of the important whys when you think about smart building protocols. And why else does it matter? Well, there's a few other reasons for that too, and let's have a look. So we're all being told, pick a road and march on, pick a protocol, uh, strap your colours to the mast, make the leap. We're all being told that the best one is the one that company's offering, which is not a new thing to your ears, I'm sure. Um, but it's always pick this one because it's the best one, and that can be confusing too. So if you're out there trying to work out how you do your strategy, we want to have a look at that. We're always being sold the dream that there's a single threaded solution architecture, um, but it always often is clear that there's quite a few choices out there. And I liken it to the Betamax versus VHS race all over again. But this time, our professional future depends upon getting it right, not just whether our kids will still love us. But call your jets and don't panic, because it makes sense to look objectively at all the options and not be pushed into the choices. Every business is different, and this is where we want to try and look at what's out there and help you guys to make a decision. So what do the options look like? Let's take a look at them at a glance. Bluetooth, a great mesh system. Everyone knows it. People have it at home. They've got experience of it. And where there's a high density of devices that can send and mesh together and receive information over short ranges, it's a great option. There's LoRaWAN, a wide area network capable of covering kilometers, and without a density of devices. Just bear in mind the transmission speed and the size of the packet data is not ideal for some applications. Then you have cellular, NB-IoT or LTE-M, for instance. They use existing cellular infrastructure to transfer data. There's a high bandwidth and there's a really, really good range. So, it's a great option possibly of not really needing too much infrastructure. There's no density of devices needed either. There's Zigbee, a very low cost mesh system. There's a glut of device types. It's good for low power data transmission, and it's a great little mesh system. And there's Wi-Fi, again, one everyone knows from their house. It's ubiquitous in most common commercial buildings now, and there's high bandwidth over quite reasonable distances, using endpoints or routers. And the real advantage here could be that you're using an in-place free infrastructure, and there's relatively low data costs in real terms. And a slight switch, we like DALI 2. It's a wired but soon to be wireless protocol too. It's more based around lighting, but you can add some added functions such as indoor air quality or blind control. Um, as I said, it's generally a wired system using a bus network, but it's soon to be wireless too, uh, and an option for you. Then there's Z-Wave, often most compared to Zigbee, a very similar system, has a much better range, but it has a smaller transmission rate in terms of sending information. We have to add Thread, as it's clearly the buzzword of the moment. It's a networking layer rather than a protocol per se, and it could use Bluetooth or other transmission layers. It has some really big players that are driving its adoption, and it aims to break down interoperability barriers, I guess, at its core. Then there's the old generals of automation and the early smart buildings, Modbus and BACnet. Most people have some understanding of those. They can be wired or wireless, um, and they're much more old school. And then bringing up the rear, and not our particular tool of choice, is the proprietary protocol. In certain instances, they come up with new devices that are groundbreaking or better performance, and we would advocate it. But often it can be simply a shackle for users. It can become very expensive, or it can become obsolete should the company exit the market or fail. So we're always a little bit wary of promoting the proprietary protocol. So there's quite a few, as you can see. Let's pick just a few and have a slightly deeper dive into them. So how about Wi-Fi to start with? The main advantage of a Wi-Fi is it's ubiquitous in commercial buildings. The infrastructure is probably in. Most places already have routers or endpoints. And from a legacy perspective, it could be a great start. And then with this in mind, often the deployment can be pretty good in terms of how much it costs. The signal strength generally is pretty good because it's a legacy thing. So it's already been fettled and worked through in your building. But the choice of IoT devices is not quite as good at the moment on Wi-Fi. The security is considered to be not as high as in other protocols. And devices are just not designed for low power use. So there's a few pluses, a few minuses there. Let's take a look at Bluetooth, for instance. It's something we all know and have experience of. It's a good option for smart buildings, but it does have its challenges too. Bluetooth's a great low energy product, as it's called, Bluetooth Low Energy, or BLE. And it can be important in smart building applications in terms of product life, devices, wireless battery devices, and how long they might last. The costs are pretty competitive because it's now a very mature wireless technology. There's a high level of standardization across devices, again, due to it being a mature wireless protocol. As a mesh technology, it can be a little more challenging to deploy for those that aren't as experienced. The security, can be an issue. The security is as good as the security you make it, but generally it can be an issue. And for some applications, the slow data transfer could be an issue. And we'll have a look at a few applications soon, but there's some of the pluses and minuses. So how about LoRa as a protocol? What would we get from that? Low power devices, great advantage. Often with LoRa, the devices sleep and wake up when they need to, just to transfer information, which is really useful for some applications. And there's a lot where you could really see the benefit of that. The range is huge, and often in open range can be up to 15 kilometers, for instance, from one gateway. Security is generally pretty good. And then often with LoRa network servers, etc., there's the ability to code further. The costs can actually be a little higher for these devices as they have a little bit more communication costs within the design. The maturity of the market is on the way, but it's yet to reach that tipping point for lower cost devices. So the devices can be a little bit more of a premium. There are some advantages there. And whilst it has an excellent range, it actually lacks in bandwidth. So what the gateway is transmitting, for instance, it cannot receive as well. And the packet data sizes can be smaller. So really, it's a perfect example of how they've got pluses and minuses across each kind of protocol, really. And then how about cellular? You know, bearing in mind we've got a few generations and variants, let's just have a quick look at that. You've got NB-IoT, which is best for low data rates, LTE, better for higher ones. One works on 2G, the other on 4G, but both will function on 5G in future. Good thing about cellular, security is inherent in cellular, it's well encrypted, a great tick in the box here for cellular. Signal strength is far superior to anything else generally that we're looking at today in terms of how far. It could be up to 50 kilometers, for instance. That is appealing in terms of range. There's no gateways needed. So it's an infrastructureless product. So easier deployment, readily made infrastructure. Typically, for that reason, it's a little bit more expensive than the others that we're looking at, both in upfront and over time costs, but it could be a really good option. And there's not so much of a choice of devices, really starting to pick up now, but not as many out there. So it's not as good across multiple applications, and it really would depend on what you want to do. And then, the LPWA availability or the cellular availability is impacted by region. So, areas in Asia, for instance, they don't have LTE-M available. So if you're trying to think of a worldwide strategy, you have to kind of think about whether all those regions will have the same. And then also the cellular, network management is always outsourced. So the mobile network operators, as a result, have less control over the network's performance. So that's sometimes a consideration. So with that in mind, the best communication protocol for a smart building is 2024, and you can see the gist of it here. It's not a straightforward, one liner. And remember, we're keeping one eye on the fact that we're digitalizing too. So it's not just about the smart building, it's about having a smart business, rather than just a smart building in isolation. So with all of this in mind, and with two obvious takeaways, the winner is, well, the best protocol is the best one for the application, and we can see that from just some of the ones we've looked at. And secondly, the best protocol for 2024 and beyond is likely, honestly, to be a mix of more than one, or in some cases several, that best fit your needs. And I think to finish off, we'll use a typical example that really shows this perfectly about how you might build out your smart building strategy. And it's a great example, this one, a hospital, but it could be any other smart building. And let's just say we already have Wi-Fi inherently in place. So we could do some of those tasks here using Wi-Fi. We could do people counting, we could do energy monitoring, and we could do something like CCTV, because we can get that live feed from Wi-Fi, and it's got good data rate. And then for lighting, for instance, we could use, LoRaWAN for the street lighting, that wide area network. We could use Bluetooth for all the standard indoor lighting, and maybe Bluetooth or Zigbee for the emergency lighting, for instance, which will be a separate system anyway. Um, Street lighting is a wider area network, so it's probably not ideal for a mesh type, whereas indoor lighting is usually so pervasive, it's perfect for a mesh. So you can see how we're going to use the right technology for the right application. For vehicle tracking, for instance, and EV charging, we can use cellular services for simple, robust, infrastructureless comms. For EV charging, we just provide the power to the far end of the car park and let the network do the rest. In this case, maybe for ambulances, we could use tracking, and it could be useful to see live info, but also it would be really good to see the historical data of where the ambulances tend to go, how often they go there. Maybe in the future, it might be a case of moving the ambulance station somewhere else for efficiency purposes, for instance. I don't think we know this kind of data. It would be really good to find out. And then also, for the wider vehicles, we could publish the info, say, as a public asset, and then everybody would understand where the shuttle bus was between the hospitals, regardless of what the traffic's like. It could be published to display boards within the hospital, so anyone trying to go within the two hospitals would understand. And then, for asset control, say of items, carts, ladders, parking spaces, any of those kind of controls, we could use LoRaWAN. So they just wake up the sensor to see exactly where the asset is, and to use that simple infrastructure. And in this case, we can show it, we could create a LoRa coverage per site. This is 2 hospitals in Nottingham that we've been working with. And with just 2 gateways, for instance, we could cover the whole area. We could also create the backbone of other future smart services using that LoRaWAN network too. Another added advantage of this is we could create geofences. So any items or assets that weren't allowed to leave one specific site or weren't allowed to enter another specific site, for instance, we could have the ability to alert the owner if this was to happen. And there's lots of other uses for geofences, which we'll cover in a separate webinar for anyone who's interested. But we could really track all of the items very simply using this method. So you can begin to see now that there'll very likely be a need for at least more than one protocol, but maybe multiple ones, to use best-in-class devices, to make best-in-class or best use cases. There might be a bit, the need for some of them to mesh. There may be the need for some of them to have wider area networking capabilities. Some might need more data or bandwidth. Some others might just send small packets of data twice per day to say this is what's happened or this is the measurement. Some others might need to broadcast live, any video feeds or anything like that. So you can see immediately from this pictorial that a strategy around IoT is key, as is the flexibility. And anyone who's sort of saying, well, why don't we just do the whole lot using Bluetooth, is probably just because it suits them, because that's the only thing they can do. But the best solutions, we think, will incorporate the best devices and the best mythology. We incorporate all of them, and you can have it ready to go. You can save money, you can deploy quicker, and you can build more powerful systems. And they communicate with each other. And in this case, with Assetbook, they're not in useless silos. So even though we might use Bluetooth and Zigbee, they can communicate together. They can trigger each other. They can automate each other. They can send information that's pertinent, regardless of the protocol or the networking layer. Most importantly, we can see them all in one single pane of glass view. So don't be fooled by the pick one protocol brigade, because all you'll create is a one-dimensional building. Be free to use the best, do the best, and to get the best. And rip up the rule book and create your own digitalized future or buildings.